Hi, let's take a look at question number 2. The figure above shows an above-ground swimming pool in the shape of a cylinder with a radius 12 feet and a height of 4 feet. The pool contains 1,000 cubic feet of water at time t equals 0 during the time interval 0 to 12. Water is pumped into the pool at the rate P of t cubic feet per hour. The table above gives value of P of t for selected value of t. During the same time interval, water is leaking from the pool at the rate of RT cubic feet per hour, where RT equal to 25 times e to the negative 0.05 t. So here we had the volume of the cylinder be equal to pi r squared h. So after we read this question, so it seems like this is a water in and out problem. So we had the rate in to the tank is P of t. So that means we cannot use P to represent the total amount of water in the tank. And then we had the rate out equal to RT. So now because we cannot use P of t to represent the total amount of water in the tank, so we had to pick another letter, another variable. So since the tank's in the shape of a cylinder, so therefore we are going to stick with the letter V because V represents the amount of water in the cylinder-shaped water body. So we're going to let V of t equal to the amount of water in the tank. Okay, so now let's continue to read. Part A. Use a midpoint Riemann sum with 3 subintervals of equal length to approximate the total amount of water that was pumped into the pool during the time interval 0 to 12. So the computation that lead to your answer. So for part A, we have to find the amount of water that pumped into. So integral 0 to 12, rate pumped into dt would be equal to the amount of water pump into. So we know that the rate goes in, the rate to pump into is P of t. So therefore we do integral 0 to 12 P of t dt. And P of t is in form of a table. So the question asks us to use the midpoint Riemann sum to approximate the integral 0 to 12 P of t dt. So now we are going to find the interval. So the total interval is 0 to 12. So we had to do 3 intervals. So therefore it's going to be 0 to 4 and 4 to 8 and 8 to 12. So we're going to use 46, 57, and 62. And the delta x is going to be 4 for each. 0 to 4 is 4, 4 to 8 is 4, 8 to 12 is 4. So delta x times the height, because it's a base times height. And the height is going to be the y values. So the y value is the one in the middle. Is it 2 to 4? The middle is 46, 4 to 8 is 57, and 8 to 12 is 62. So the middle. So now we are going to do 4 times 46 plus 4 times 57 and plus 4 times 62. And then we're going to use our calculator. And then we're going to get 660 cubic feet. So we finished question number 2A. Let's take a look at B. B, the question said that calculate the total amount of water that leaked out of the pool during the time interval 0 to 12. So for B, integral 0 to 12, the rate leak out dt equal to the amount of water leaked out. So here we get 0 to 12. The rate is RT. So we put RT dt. And then we're going to make y1 equal to 25 times e to the negative 0.05x. And then integral 0 to 12 y1 dx. Okay, so now you're going to use the So to get the integral, you do Mach 9, okay, and then you get your function 1 and dx. So you got 225.594. So we got 225.594 cubic feet. So the amount of water let out will be this much. Now let's go to part C. Part C says that use the result from part A and part B to approximate the volume of water in the pool at t equal to 12 hours. Round your answer to the nearest cubic foot. So we know that we already used B at t equal to the amount of water in tank, okay, for any time t. So we talk about it at the beginning of the question. So now we say that we want to find that amount of water at t equal to 12. So we say V of 12 equal to integral 0 to 12. The rate in will be P of t, and then the rate out will be R of t. So that's what we did in part A and part B, and plus initial amount, which is 1,000. So now we are going to use the answer we got before. So we got 660 minus 225.594, and then plus 1,000. So now you're going to type it into the calculator. So you will get 1434.406. So we round to 1434. So 1434. So we got 1434 cubic feet. So that will be the approximation. So now let's go to part D. Part D is said that find the rate at which the volume of the water in the pool is increasing at t equal to 8 hours. The rate at which the volume of the water, the rate of the volume of the water. So we have V of t equal to the volume of water. And then the rate will be V prime t. So at what time? At t equal to 8. So based on what we did in part A, B, C, so I know that V of x equal to integral 0 to x t of t dt minus 0 to x rt dt, and plus 1,000. That will be V of t using the rate in minus rate out plus initial amount. So V prime of t is going to be P of t minus RT, because that will be the rate in minus rate out. Then at t equal to 8, so it will be V prime of 8 equal to P of A minus R of 8. So P of A, we look at the table, okay? So we're at the table. That will be 60. And RA, we have to use the equation, 25 times e to the negative 0.058. And then we use our calculator. So we got 43.242. Okay, so now that will be the rate of the volume at t equal to 8. Per hour. So cubic feet per hour. Now we're going to continue. How fast is the water level in the pool rising at t equal to 8 hours? So now we are going to find the rate of change of the water level. So which h prime or dh dt. So now this one does not give you the h. There's another formula we can use. So because the shape of the tank is a cylinder, so you can use this formula to find the volume of the water at any time. You can also use V equal to pi r squared h because it's a regular cylinder. So here we have the h. So now V is function of time, we know from here, okay, and r and h. So we're going to use the product rule. So now we're going to do u equal to pi r squared and v equal to h. U prime equal to pi times 2r times dr dt, and then v prime equal to dh dt. So we're going to use the product rule. So we're definitely going to substitute the dv dt and dr dt. So what is dv dt? dv dt is the v prime because this is this. It's just using two different ways to find the volume of the water body. So this one is using the rate in and rate out. This one is using the regular volume formula for a cylinder. So this dv dt is this one. So we're talking about the same time, t equal to 8. So therefore, it's equal to v prime of 8. We found it as 43.242 because it's talking about the same time. So how about the RDT? We also need it. So now we're going to take a look at the cylinder shape. We know this tank have the fixed radius because as the water go in, the radius never change. It will not become bigger or become smaller. So the radius never change, stay at 12. So therefore, the dRdt equals 0 because the radius never change the length. Okay, it stay the same as 12 forever. So now we know that the u prime from here, so we know that u prime is going to be 0 because pi times 2r times dr dt. This is 0. So now you go back over here, so we get dv dt equal product rule u prime v plus uv prime. So dv dt equal to, because the u prime equals 0, so we get 0 plus is 0 because the dr dt is 0. Then we got the u pi r squared times the dh dt. So now dv dt equal to pi r squared dh dt. And then at t equal to 8, our dv dt is 43.242. And pi and radius stay as 12 forever. As we said before, the tank never change its radius. So now we got 43.242 equal to 144 pi dh dt. And now we're going to divide by 144 pi. So now we're going to use our calculator and divide it. So we got 43.242 divided by parentheses 144 pi, and then we got 0.0956, and this is one dimensional, so therefore it's going to be V and the time is hour, so therefore it will be V per hour. So we finished question number 2.